Okay, so this is a set of answers and solutions for the review solutions test. I'm skipping the first part because those are all just definitions. I'll include that when I post this video. I'll include a link to those. All right, so first one. What is the molarity of a 10-gram NaCl solution, 100 milliliters of water? So molarity, that's moles over liters. NaCl, if you use a periodic table, Google it, is 58 grams per mole. So we have to take 10 grams of NaCl solution and convert it to moles. And this is kind of what's always stuck. Like if you ever have grams, convert to moles. It's always going to stick. Like it's always going to work for the rest of the year. So just keep that in mind. So we got 10 grams. We want to get moles. So for 1 mole, we have 58 grams of salt. (10) divided by 58 and get 0.17 moles. Now for our bottom number, we got 100 milliliters. We want to convert that to liters, get rid of the milliliters. For every 1 liter, you have 1,000 milliliters. So 100 divided by 1,000, 0.1. So all you're really doing is 0.17 moles divided by 0.1. That gives you 1.7. That's your molarity. Next one. How many grams of potassium sulfate must be added to make 250 milliliters of a 0.1 molar potassium sulfate solution? So in this case, we're still dealing with moles or molarity. This time they give us the molarity, they give us the liters, and we have to find the moles and then convert that to grams. So plug in the numbers here. We get 0.1 for the molarity. We don't know the moles. And we know the liters is 250 milliliters. Now 250 milliliters, you want to convert that to liters. You just divide it by 1,000 like we did up there. So that should be 0.25 liters. So there's your bottom number. Again, all you're doing is 250 divided by 1,000. That'll convert it to liters, from milliliters to liters. So now we just solve for moles. To solve for moles, you can just multiply each side by 0.25. Write it up here. So 0.1 times 0.25. 0.025 moles. We now need to convert that to grams of potassium sulfate. If you look online, potassium sulfate is 174 grams per mole. So we're going to take this 0.025 moles of potassium sulfate and convert it to grams. Then we have our final answer. So moles, we want grams. We want to get rid of the moles. For every 1 mole, we have 174 grams. So 0.025 times 174 gives you 4.35 grams. So again, that's 4.35 if you can't read that. That's your final answer. Our next one, 200 milliliters of water is added to 15 milliliters of a 4 mole NaCl solution. What is the concentration of the dilute solution? So this is an M1, V1, M2, V2 problem. The way you know that, the hints you'll see is they might mention a dilute solution. I might mention a dilute solution, or you're going to see 2 volumes, or you might see 2 molarities. If you see multiple molarities or multiple volumes, like multiple amounts in milliliters or multiple amounts in liters, that's a sign telling you it's M1, V1, M2, V2. And we'll just plug them in order. So we'll say we don't know M1. Say our V1 is just 200. We'll say M2 is the 4.0 molarity. And we'll say V2 is the 15 milliliters. Just keep in mind that when you solve for, never mind, I was going to say a liter thing, but it's in milliliters. We're not solving for milliliters, so our M1 is just going to be molarity, and boom, there we're done. You can answer this by dividing each side by 200. Cancels out over here. So 4 times 15 divided by 200, 0.3 for the molarity. Next one, how many milliliters of a 3 molar NaBr solution are needed to make 100 milliliters of a 0.25 molar NaBr solution? So again, that same hint I just mentioned, we have 2 molarities here. So we're dealing with M1, V1, M2, V2. We got one volume. We're going to find the other volume. They're asking us how many milliliters, so we have to find an answer in milliliters. So I'll just plug them in order. We know that M1, we'll say M1 is 0 or 3.0. We'll say we don't know V1. We'll say M2 is the other molarity. V2 is the one volume they give us. That's in milliliters, so your answer will be in milliliters. Do the same thing we did above, just divide. 3 cancels out on the left. So 0.25 times 100 divided by 3 will give you your answer. So V1 is 8.3 milliliters. Your answer is in milliliters because this one was in milliliters. So your answer, your new volume is in milliliters. All right, what is the molarity of a solution containing 10 grams of glucose and 200 grams of water? So in this one, they're giving us, we got grams. They ask for molality first off. So that's moles over kilograms. And they give us the grams of water, which is actually very useful because we know that's going to be our bottom number. And we just have to convert the 10 grams of glucose to moles. And we're going to convert this 200 grams of water just to kilograms. So that's a little tricky because usually when we have grams, we always convert to moles. In this case, you only have to convert one of them. You have to remember that water is your bottom number. That's the kilograms. So 200 grams of water is, you divide that by 1,000 to get your kilograms. So it should be 0.2 kilograms of water. So there's your bottom number. That's our kilograms. To get our moles, we're going to take that 10 grams of glucose and convert that to moles by dividing by the mass of glucose. They tell us the mass of glucose is just 180. So 10 divided by 180. 0.055 moles. So there's your top number. So to find the molarity, just to rewrite it all, it's 0.055 moles divided by 0.2 kilograms of water. At 0.27 molal, little m. Next one, what is the molality of a solution that contains 4 moles of KNO3 and 5 kilograms of water? They tell us that the molar mass of KNO3 is 101.11. So molality is moles over kilograms. Again, they tell us the molar mass of KNO3, but we don't even need it. That's kind of a distractor. In this case, you just got 4 moles, so you put that on top. We got 5 kilograms of water, so put that on the bottom. And there you go. Divide and get your answer. little m, molality, 0.8. All right, the rest of this is net ionic equation stuff. And I'm going to keep this very simple because this is the way I'm going to do it on the test. And usually you can make it more complicated. And I'll do like some of the steps to it. But I just want you guys to understand that you can keep this very, very simple. So AgNO3, it's aqueous solution. Sodium sulfide, NaS. And there's a typo here. It should be Na2S, but it's not super important for how we're going to do this. And what is that going to make? They tell us silver sulfide. You're in solid silver sulfide. So that's Ag, that's the silver part. Sulfide, it's not sulfate, it's sulfide, so it's just S. And that would be Ag2S. And honestly, even if you didn't get Ag2S, if you were able to just get Ag2, you'd still be okay for how we're going to do this. That's a solid. They tell us it's solid. And they don't mention what the other thing made is. Now, when you're looking at this problem, to get the final answer, you don't actually have to figure out what the other thing made is. So let me show you the final answer, and then I'll come back and we can fill in the blank here. So the net ionic equation, which is what the question's really asking, what's the net ionic equation? That's really what we want. I put here, write the chemical equation, which is what I'm going to finish here in a second. But the most important thing for you to be able to figure out for the test is net ionic equation. So look at your solid and say, okay, how do I break that down? So the net ionic equation would be something like Ag and plus aqueous, something like that. And Ag is a positive 1 here, plus S, so negative 2 ion, that's aqueous, makes Ag2S. That's it. That's what you need to be able to figure out. You need to be able to say, okay, what's the solid? The net ionic equation is just a breakdown of the solid. That's it. So this bottom part right here, that's your net ionic equation. Now up here, we're going to have the chemical equation. Finishing the chemical equation, we just got to look at what's not included on each side. So on the left side, we got your silver. On the right side, we got silver. On the left side, we got your sulfur. On the right side, we got sulfur. So what else is left? We got sodium over here, so we can put sodium. And sodium is a metal, so it's going to be first. Metals are always first in compounds. And then we got NO3. That's the other guy. So NaNO3. So this guy over here is your chemical equation. And that's all you have to be able to do for the test. Now, net ionic equations get more complicated, as you might have saw if you looked at the presentation, but we're keeping it very simple. You don't have to be able to break down each ion. You just have to be able to say, okay, what's a net ionic equation? Recognize one when you see it. What's a chemical equation? And recognize one when you see it.